Moving on to the next couple sections, we're going to actually combine the two together and talk more about using function notation to describe certain rules. And we'll now kind of relate it a little bit more to kind of a linear equation context, or at least an algebraic equation context, and not just a general function graph. So let's see if we can kind of translate into that framework. So here we have four functions. Here are descriptions and equations that represent four functions. Match each equation with a verbal description that represents the same function. Record the results. All right, so if it's possible to pause right here for a moment, that would be good to see if you can maybe match on your own. And then you could unpause and see if you've got the right answers. So if it's possible to pause right now, you go ahead and pause. Okay, so let's see if we can match these up. So I think maybe the best way to do it is to maybe start with the statements over here. So let's see what we've got. So A says to get the output, subtract 7 from the input, then divide the result by 3. So the first thing that we're going to do is subtract 7 from the input. So that's kind of like x minus 7. And then we're going to divide by 3. So we're going to have the x minus the 7 and divided by 3. So that down here looks like that would be that function, the k of x function. So that matches with description A. So that's the k function. All right, let's go to a different color. So let's talk about B here. To get the output, subtract 7 from the input. So again, we're kind of talking about x minus 7, then multiply the result by 3. So x minus 7 and then times 3. See if you can figure out which one that would be. So remember, when we have a number, a coefficient that's called next to parentheses, these are being multiplied. So there's the x minus 7 and then also multiplied by 3. We would do the x minus 7 first because it's inside the parentheses and then multiplied by 3. So that's the one right next to it. So the g function goes with description B. All right, narrowing it down. To get the output, multiply the input by 3. So it's kind of like x times 3 or 3x, and then subtract 7 from the result. So you would have x times 3 or 3x and then minus 7. And so that seems to go up here with function f. And then, of course, process of elimination. We kind of know what the last one is, but I'm going to go ahead and read it anyway. To get the output, divide the input by 3. So divide the input by 3. So that's like x divided by 3. And then subtract 7. So that makes sense that that would be this one here. So that would be description D. All right, so we matched the descriptions with the functions. Now let's answer some questions about that. All right. For one of the functions, when the input is 6, the output is negative 3. Which is that function? F, G, H, or K? Explain how you know. All right, so we basically have to think about if the input is going to be 3, the input's going to be 6, it produces an output of negative 3. So essentially we can just start doing some trial and error here. So if we have the input is 6 in the first one, so if we inputted 6 here, that'd be 3 times 6 minus 7. 3 times 6 would be 18. 18 minus 7 would be 11. So that does not get us an output of negative 3. So it's not that function. All right, let's move on to the next one. If we put 6 in for x, all right, so we'd have to do the parentheses first here. So 6 minus 7 would be negative 1. And negative 1 times 3 would be negative 3. Oh, looks like we found our answer. That's the one. All right, so we have the g of x function, which is equal to 3 times x minus 7. So that's the function that we have, the g function. And let's just show that works. So if we put 6 in for x, so if it's g of 6 is our input, so that would mean 3 times 6 minus 7. All right, that would be, all right, so that's our input of 6 right there. That would mean 3 times negative 1. So 6 minus 7 is negative 1. And 3 times negative 1 is negative 3. So there is our output. So 6 was our input. We put it in right here. And then negative 3 was the output. All right. Which function value, f of x, g of x, h of x, or k of x, is the greatest when the input is 0? Which one is the greatest when the input is 0? All right, so let's actually do some comparison here. It's going to take a little bit of work, but let's see if we can make it happen. So let's start with the f function. I'm going to stick with the color coding here. So the f function was f of 0, and the f function is 3 times x minus 7. So 3 times 0 minus 7. So we're doing the first question here when the input is 0. So that would be 0 minus 7. 3 times 0 is 0, so 0 minus 7 is negative 7. Okay, we don't know the answer to the question yet because we're trying to figure out which one is greatest when 0 is the input. All right, so let's do the g function now. So g of 0, so that's the second function. So if we go up here and we put 0 in for x in the second function, that would be 3 times 0 minus 7. All right, we got to do parentheses first. So 0 minus 7 is negative 7. So it'd be 3 times negative 7, which is negative 21. Because that's the g function. All right, the h function. So h of 0. All right, so if we put 0 in here, so that would be 0 divided by 3 minus 7. So 0 divided by 3 minus 7. 0 divided by 3 is 0. 0 minus 7 is negative 7 as well. So we have another one that comes out to negative 7. And finally, our k function, which was the last one. So k of 0. So that'd be up here. So in the numerator, we have 0 minus 7. Again, I'm looking up here. So 0 minus 7 divided by 3. So 0 minus 7 divided by 3 if we put 0 in for x. So that'd be what, negative 7 divided by 3, which is essentially the fraction negative 2 1/3, or negative 2.3 repeating if you got a decimal here. Okay, so now we can answer the question. So which is the greatest of this group here? Which one of these numbers is the greatest? Now, by greatest, we mean really the think of it as a temperature. What's the warmest temperature here? Sometimes people will see the negative 21 and say that's the greatest because it's the biggest number we see. But actually, the greatest number, the warmest temperature, is, in this case, the least negative, which is the last one down here, this one right here. So k of 0 is the greatest of this group. That's the biggest one, or at least the warmest one, the ones that's closest to the positive numbers of that group. Okay, now we're not quite done with the question though, because we're given another input here. What about when the input is 10? So I'm going to separate this out here and say, all right, let's do the same thing when the input is 10. I might go through this a little bit faster now because we sort of have the template above here. So the f function, that would be 3 times 10 minus 7. So remember, like up here where we put 0 in for x, now we're putting 10 in for x, the input. So 3 times 10 is 30. 30 minus 7 is 23. So that's that one. All right, g of 10. All right, so we're going to put 10, and up here where we had 0, we're going to put 10. So 3 times 10 minus 7. Got to do parentheses first here. So 10 minus 7 is 3. So this would be 3 times 3, which is 9. All right. H of 10. So that would be 10 divided by 3. So we're just putting 10 in for the input, like kind of like where we put 0 in above here. So 10 divided by 3 minus 7. All right, so that would be kind of like what we had before, 3 1/3 minus 7. And so if you're doing your fraction subtraction here, go down 3 1/3, that would leave us another 3 2/3 in the negative side. So negative 3 2/3. You could also get the decimal there, 3.3 repeating minus 7, you get negative 3 and 0.6 repeating. So that challenges your fraction skills a little bit there. So let's move on to our last one, and we have k of 10. All right, k of 10, you put 10 in, actually, I used the wrong color here. I'm going to keep color coding here. So k of 10 was red. All right, so that would be 10 minus 7 divided by 3. If we look back at the k function, that's how that would work. That's a little bit easier. 10 minus 7 in the numerator is 3. 3 divided by 3 is 1. So which one of these is the greatest? This one's a little bit easier to recognize because they're almost all positive numbers, and we want the one that is the highest positive. So that would be the f of 10 function would be the greatest because it produces an output of 23.